Otherwise, my thought was to try some of these together, maybe some of the harder ones, and then to give you some more time to work. Between today and Monday, I don't even remember off the top of my head when I had 2.9 due. I think it was next Wednesday, maybe next Tuesday. Either way, 2.7, 2.8, 2.9 is not a lot of new information. It's basically two formulas, product rule, quotient rule. 2.9 is just more derivative formulas. So it's not something you have to learn, like power rule was easy to learn, but yet it was something you had to learn how to do. You had to learn how to rewrite the equations. Trig derivatives are really nice because you don't need to be able to rewrite them. You just take whatever trig function you have, and that's the derivative. I mean, I know you guys dislike trig. I'm just trying to tell you that trig derivatives and second half of the year trig integrals are very straightforward because you have no choice on how to do them. Power rule, while it feels easy, can be more complicated because it has to be written a certain way. And we are going to learn, a couple other derivatives. But virtually everything can be done with the things we've learned already. I feel like we can probably just say the answer to number one and then just move on. Who did I call on last? Rowan, I think I called on you last. You're still on your Chromebook or laptop. Jeez. Okay, Rowan, who are you going to choose? I would pick somebody else who is on actually everybody else put him away now. Nice job. Or at least nobody I can see. Right there. Luke, help me with the derivative for number one.
First one, derivative of adding derivatives.
Good. The plus sign means you do them separately.
So derivative cosecant is negative cosecant x cotangent x.
Good.
And secant x and
Did I hear that?
and then I was gonna write it down.
I didn't hear you say the derivative of the secant. I'm sure you did. I just didn't hear it.
Sec x constant.
The derivative of secant is secant tan. Good. I mean, yeah, you literally just write them down and that's the answer. And those don't really simplify. I mean, if you wanted to put a lot of work, you could make it sort of simpler, but not worth it. Okay, good. I want the next person to tell me how to do number two, but we're not going to write it down because I'm moving to the harder ones farther below. Luke, who are you calling on? Pick somebody who's avoiding eye contact, who I don't think anybody else is using technology. So Devin, all right, sounds good. Devin did not want to be called on. I saw that. That makes it the perfect choice. All right, Devin, tell me how to do number two. I don't even need the answer. I just want you to tell me how to go about doing it.
What I do, just what's it called?
Yep. Multiplication rule if you can't think of product rule. Yep. Oh, that's all. More. I mean, that explanation is correct, very succinct, but correct. Product rule, so you are going to need to know the derivative for cosine and for tangent to be able to fill out the four parts. Now, it's very possible something there would have something in common to factor out. Other than that, that's just a straightforward derivative. Okay? Good. Devin, choose somebody. Drew? How would you go about doing number three? You can. Quotient will be 10 times harder. It wouldn't be wrong though. You definitely could. Frequently, whenever you're doing a calc problem, whatever comes to your mind first is probably the best way to do it because that's what you can picture. That would be correct for number three. I would definitely not recommend it though.
Could you add a common denominator with
You could. Essentially what you're saying would be to make one big fraction, which would require one big quotient rule. Doesn't sound easier. And you pass it on to the next person, it's okay.
I think Abe got this.
Abe? He doesn't look like he's got this.
No, I do not.
Oh dear. Ryan's got it? Wait, really? Nobody can see what to do on number 3?
Is it like since it's 1 over secant x, secant is 1 over cosine, you change it to
1 over secant is cosine of t.
Yeah, 1 over cosine.
The second term would turn into 2/3 times tangent of t. And so both of those derivatives would not require any kind of work. It's just the straight derivative. For trig, if you have a very quick, easy simplification, it's generally better to do that. But I will still stand by, quotient rule on both of them would have been 100% correct and fine. It would have been equivalent. It would have been 10 times worse, but it would have been equivalent. That's all you care about. Okay, good. 5. 4 is super straightforward. The only difference on 4 is it's got an alpha symbol instead of t or theta. Did any of the other ones have theta? Yeah, number 1 had theta. Traditionally, whenever you're dealing with angles, they'll use the variables theta, alpha, or beta. Time, I guess, theoretically works, but they usually reserve x for non-angle ones. Sort of, Abe.
Yeah,
Do you want to help me on 5, or do you want to choose somebody?
I can try to help.
Okay, as long as we're not going to pick Elise for the 18th time in a row.
Sounds good.
Okay. What would you do on 5?
Probably do the denominator first.
What does that mean to do the denominator?
Product rule, do the denominator,
You can.
and then do the quotient rule, the whole thing.
You can. That is absolutely a method to working it. So you were essentially just basically saying, figure out f, g, f prime, g prime. G prime would be the product rule, so it'd be a lot bigger. But then take those 4 parts to make a giant quotient rule. Absolutely acceptable. Anybody think of a different way?
Can you just take out the cosecant from the denominator and multiply sine of y over tan of y times 1 over cosecant of y, and then convert the.
I'm not following any of that. I mean, it could be just because I can't hear you good enough. In short, what were you trying to do?
Convert the cosecant that is multiplied with the tangent on the denominator to a sine.
On the top?
Yeah, not to a sine multiplied by sine of y over tan of y.
If you convert cosecant into sine, it would have to be moving to the top of the fraction as a sine. So then you would have sine times sine on the top of the fraction. On the bottom of the fraction would be tangent. Okay? Could do that. It actually works out to be pretty much the exact same process because your numerator would have 2 terms that you would have to do a product rule on. So you could do that, and sine and cosine are easier derivatives for sure. Do you guys not remember pre-calc training here? This is supposed to be an automatic thing when you see trig. What's the first thing you do if you have a bunch of trig things together? Oh, I thought you were trying to answer. Everybody keeps playing with their hair when it's time to call on people. Ella, you had a day to rest your brain. That means you know exactly what's going on today. You actually didn't miss anything, so it worked out fine. Okay, what would you do if you had a bunch of trig things? Do you remember doing trig identities?
Yeah, but I don't remember.
Oh, well, that's not helpful at all. Oh, dear. Barbode, you got this. We haven't done anything. You can't be lost when we don't do anything. Oh, Winston?
Do terms of tan Sine over cosine.
That sounds hopeful. Why would you do that?
So you can cancel out maybe.
It's a good thought. Turn everything into sines and cosines to see if anything cancels or combines. That was usually the number one rule for trig identities in pre-calc, is when you are working with a lot of trig formulas together, is you find out if they combine. What you're going to find is tangent is sine over cosine, cosecant is 1 over sine, the sines cancel. So you would have sine on the top of the fraction, on the bottom of the fraction, 1 over cosine. And you would, instead of having a fraction on the bottom, do the keep change flip. And this would turn into sine times cosine, no fraction. And then you could do product rule. Now, again, it would not be wrong whoever first, Drew, was that you? Was that long ago? Who's the one? Oh, that was you, Abe.
Yeah.
So, it feels like 5 minutes ago. It wouldn't have been wrong from the very beginning to just make it a horrible problem and then fill out all the parts. The downside to that, as you should have discovered, in section 2.7 and 2.8, you had to solve the derivative equal to 0 a bunch of times. If you're trying to solve anything, having it factored is much easier. And so if you would do 5 the long way, your derivative is so horrible looking that it would make solving anything hard. And so being able to do a problem the most efficient way is helpful because you can find answers easier from it. So there's going to be lots of methods for us to find answers. Even if they are correct, they might be a lot more difficult than needed. And so part of calculus training is learning how to do things efficiently, right? Like math people, we are lazy at the core, and we want to do things with the least amount of work as possible. And in the business world, that is celebrated. That is efficiency. Like, not even joking, that is how Microsoft used to hire people. They would specifically hire the laziest students that had decent grades because they knew that they would do the shortcuts to find answers. There's nothing wrong with that. That is efficiency. Okay, I think we should do number 6 together. Especially given how bad the previous 5 went. I actually was not going to really do any of these, but given that nobody knew the answers to those, we should really do this one. Who should we call on first? We should call on Thea? Yeah. All right, how do we start number 6? What 2 things do we need for the tangent line? Because I see write the equation of the tangent line, even though it's written line tangent.
The point and the slope.
Good, we need a point and a slope. The word slope immediately tells us derivative. Good. So I need you to choose somebody who's going to find that derivative and then, I don't know, work stuff out.
Okay, I think Audrey.
You think so?
Yeah, I think so.
Okay. We'll see if she agrees. Yeah, you got this derivative?
Of what?
We're
What are we
just going
doing? What
over
are we
the test.
deriving?
Sorry, what?
Which part are we deriving?
There is only one equation. It's on your paper. You don't
Oh,
have to look
that-
over me. Wait. Oh. All right. How can you not even be on that page in the packet?
Give me the first one.
Well, what good does that do?
It's helpful.
Okay.
Would it be like both? Would you split it up into 2, like sine of x over sine of x?
Good. Very
And
good.
then tangent of x, plus
Yeah.
tangent of x over sine of
That is 100% what I would do as well. We don't have to do it that way, but that is absolutely what I would have done.
Okay, and then does it just cancel out? Like you just get rid of the sine of x over sine of x?
It turns into 1.
Oh, and then so it'd be 1 plus tangent of x over sine of x, which would be, I don't know. Oh, it would be,
So sine of x over cosine of x times 1 over sine of x would be 1 over cosine of x, which is secant.
yeah, secant.
If you write it down, I mean, like, doing it in your head is not always easy unless you've done it a lot. But writing it down, it should turn into secant if I did that correctly. That was very good. You weren't even on the right page and you nailed that one. Feel good today. Okay, now, tell somebody to do the derivative of that. Because we don't have to use the quotient rule anymore because it's no longer a quotient. That is exactly why I would have changed it as well. Barbo's got this?
Sure.
Okay,
Yeah, he's got it, he's got it.
Alright, so the 1 is gone.
good,
And then secant of x is
Yep.
secant of x tan of x.
perfect. The derivative of 1 is nothing, the derivative of secant is secant tan. Now, if you would have done the quotient rule from the very beginning, it would have simplified all the way down to secant tan. With a lot of work, but it would have simplified. Okay, Barboda, I need somebody who hasn't answered yet today.
I don't know. You pick.
Arjun? I don't think you answered, did you? Oh, you volunteered for one.
Yeah. Do you want me to answer?
Sure, just because I don't feel like picking anybody else at this point.
So, do you want me to like substitute in this?
Oh, what would you do next? I mean, there's actually a couple different directions we could go, because we're trying to find the point in the slope and we have neither.
So I would substitute 2 pi over 3 in the derivative.
In the derivative,
Yeah.
to find the slope, yes, we can do that. So h prime of 2 pi over 3. So we have a 60-degree angle in quadrant 2. You know what, I'm not even gonna try to picture that in my head, it's too much work. So we've got a 60-degree angle in quadrant 2, which makes this 1 to 2 to square to 3. Left is negative, up is positive.
It's negative 1/2.
So secant is gonna be cosine's answer flipped upside
Yeah,
down.
so-
Cosine is negative 1/2,
So it'd be
negative 2. So we would take the negative 1/2 and flip it upside down. Tangent, opposite over adjacent, negative root 3. Okay, so our slope is positive 2 root 3. Okay, nice job. Alyssa's gonna tell us how to find the rest of the point.
For the way we're just plugging x into the numerator.
Perfect. You're gonna plug that number into the original f of x, or h of x, I guess. So 2 pi thirds, sine of 2 pi thirds, square root of 3 over 2. This is gonna be the worst answer of all of them, isn't it? Oh, wait. I'll back up. I'm not gonna plug it into that one, I'm gonna plug it into the easier one. 1 plus sine of x. So, secant of 2 pi thirds, I think I said sine, but secant of 2 pi thirds, we already did that one, was negative 2. 1 plus negative 2 would be negative 1. That was definitely a lot easier than doing a fraction with fractions. Okay, and then we need a last person. Jamari, how do I write the equation of the tangent line? I can give some guidance if you want it. Yes? Okay, tangent line has, not has to, but we always will write it in point slope form. So it's gonna be y minus y1, mx minus x1. So you've got the info right there to write it with. Perfect. Now, the answer is kind of horrible looking, but that's okay, because that's exactly how we're supposed to write it. They usually do not have you simplify this. If you simplify it, it's fine, but even on multiple choice answers, they frequently do not change it past this. The only thing they may do is subtract 1 from both sides so that it says y equals. But I'm not a fan of that. I like it like this better because it tells you where the numbers came from, what they're for. Okay, so I will tell you the homework in 2.9. I don't know if anybody started it yet, but the homework in 2.9 is essentially the same thing as 7 and 8. So it has product rule in it, it has quotient rule in it, pretty much exactly like these examples. And then the only difference is it now includes all 6 trig functions. So 2.9 is actually a pretty decent representation of the second half of the unit. Would you guys like me to make up like a quiz for Monday that is, I think the last section we did was up to 2.5, maybe 2.6? Do you want me to make like a sample quiz for the second half of this? Okay, I can do that. Okay. All right, so at this stage, the goal is we've learned everything in the packet, like all the sections. So your goal is to try to make sure that you have gone through every section, finished up the homework, finished up what you are confused on, and some of you are kind of behind on that. Some of you are doing great pacing wise. Like quite a few people already have 2.8 turned in. It gets a lot worse in Calc if you procrastinate. So I've been trying to give you extra time to get the homework done because I get that some of you are super busy. And so the delayed turn-in dates are for those people who are really busy, either with sports or jobs or, you know, just things that take up time. If you are a person that has lots of time and you're waiting to the end every single homework period, which for whatever reason, there's always some, I've had at least 1 or 2 people every time turn them in at like 12:15, 15 minutes after they're due. Like quit waiting until the deadline to do things. I get that that's what deadlines are for. I don't like how far along out I've been putting them, but I'm doing it just for the people who are busy. So, I mean, I can't directly like, I'm not gonna take points off if you're procrastinating, right? Unless you turn it in late. But too many people in here are just putting things off. And it will get far worse in Calc the more you put things off. Like we're already done with 2.9, even though the 2.8 homework isn't due yet. You're gonna start learning new things when you're still working on previous sections. That is absolutely gonna start frying your brain soon. You're not gonna be able to learn something new because you still haven't figured out how to do the old stuff. So kind of stop procrastinating when you can and get caught up. I know our test isn't until next Friday, but I mean, we essentially have an entire week for you to catch up. But I guarantee some of you are still gonna wait until Thursday night. And you are the people who are 100% gonna be doing the retakes. And you're gonna waste even more of your time doing a retake. Get ready for it the first time. I will happily help you try to get ready as much as I can. But pretty much the onus is on you guys to plan it for yourself. If you want me to help you plan it, I can. Get things done before. That means you will be ready for the test. Not having to retake it saves you a ridiculous amount of time. I mean, you should see that pretty soon. Those who retook the first test already know that it took up way more of their time than they wanted. So, I'll help you guys with whatever. But let's get moving. You guys clearly need help on trig.